Find the equation of the line that fits the description. The line passes through the point -7, -5 and has 0 slope. There's a couple different ways to approach the problem. One way would be a geometric approach. Go ahead and sketch a graph of the line and then determine the equation based on the graph. The second approach would be purely algebraic. Let me go ahead and illustrate the geometric approach first. What we'll do is we'll first of all plot the point -7, -5, and then we'll draw a line through that point that has 0 slope. So first of all, go ahead and sketch the x and y axes. The x-axis is horizontal. The y-axis is vertical. So start by looking at the point -7, -5. We start at the origin and go left 7 and down 5. And this is the point -7, -5. Next, focus on 0 slope. The line has 0 slope. So we'll write down that the slope is equal to 0. Now you may recall that slope is equal to rise over run, and so it's helpful to think of the slope as a fraction. And when we have a number like 0, we can always write that number over 1 to create a fraction. So in this case we could think of 0 as being 0 over 1. 0 divided by 1 is equal to 0. But the advantage of thinking of it this way is that we can think of it as rise over run. So from our point -7, -5, we can rise 0, don't go up, don't go down, just stay in the same position, but then go 1 unit to the right and plot a new point. Do the same thing again, rise 0, run 1, and that takes us to another point on the line. And then just continue that process until you start to see the line. In this case, after plotting a number of points, we begin to see that the line passing through -7, -5 with 0 slope is a horizontal line. So I'll draw the line that goes through these points. And our goal is to write an equation of that line. And what we want to recall is that the equation of a line, a non-vertical line, has the form y is equal to mx plus b. So I'll write y is equal to mx plus b. And in this equation, m is the slope. And b is the y-coordinate of the y-intercept. So we have y is equal to, our slope is given to us as 0. So we'll substitute 0 for the slope. And then multiplied by x plus the y-intercept. And our y-intercept is right here. Our y-intercept is where the graph crosses the y-axis, and that's at y is equal to -5. Specifically, it's the point 0, -5, but we're interested in the y-coordinate, which is -5, so we have plus -5. then we just simplify, and we have y is equal to 0 times x, which is 0, plus negative 5, that's negative 5. Y is equal to negative 5. And that is the equation of our line. Y is equal to negative 5. Now that kind of makes sense because every single point on the line has a y coordinate of negative 5. So y equals negative 5 describes all the different points on the line. Now at the beginning I mentioned there was a purely algebraic way to approach the problem, so let's focus on that for a moment. And we could have started off with y equals mx plus b, and we were given that the line has 0 slope, so we could have substituted 0 for m. So we would have y is equal to 0x plus b. And then this equation has to be true for any point that is on the line. And we know that the point negative 7, negative 5 is on the line. So what we could do is to substitute negative 7 for x and negative 5 for y. So using our original point, the first number is the x, the second number is the y. So substitute negative 5 for the y and negative 7 for the x. So y is equal to 0 times negative 7 plus b. Now this allows us to solve for b. We get negative 5 is equal to 0 times negative 7 is 0 plus b, and therefore b is equal to negative 5. So the equation is y is equal to 0x plus negative 5, and when we simplify that it simply becomes y is equal to negative 5, which agrees with what we found before, but it's just purely an algebraic method for finding the equation.